In this video, we are going to look at writing equations of lines. A thing to keep in mind when we're writing equations of lines, there are two key things that we need, two pieces of information. We're always going to have to find a slope, and we're always going to have find a point on this line we're looking for. Sometimes those might just be stated, given to us at the beginning of the problem, or sometimes we'll have to use some information in the problem to figure them out. As I work through these examples, and we've got 5 examples in this video, the 3 forms of the line that I'm going to be using are listed here: the slope-intercept form, the point-slope form, and the general form. So if you're not familiar with those, you might want to take some time and study them and look over them. Okay, so for our first example, we're going to start with the most basic one. Find the slope-intercept form of a line that has a slope of -2 and passes through the point -5, 3. So this one is nice because they just tell us straight out the slope is -2 and the point is -5, 3. So we can fill those right into one of the forms of the line that we want to use. I'm actually going to show you 2 different ways to do this one. A lot of students are most familiar with the slope-intercept form, and we can use that here. We would fill in our slope is -2. That goes in place of m. And then we'll use our point, -5 is the x value, and 3 is the y value, to solve for b, the y-intercept, because we don't know the y-intercept yet. So we just need to do a quick little solve here. We get 10 plus b, subtract that 10 from both sides. Turns out that b is -7. So we can go back to our slope-intercept form. Y equals -2, the slope given in our problem, x minus 7, the y-intercept that we just calculated. And since this problem asks for our line to be in slope-intercept form, we're done there. We could have also done this one using the point-slope form of a line. In that case, we plug our point into these spots where we have x1, y1. So y minus 3, our slope, m, is -2, and x minus a -5. These 2 minuses together cancel each other out. So we'll distribute that -2. And then to finally get it into the slope-intercept form that it asked for, that means solving for y. So we add 3 to both sides. And there we, oops, sorry, not 10. I was just copying things down too quickly. -10 plus 3 is -7. So you can see we ended up with the same line. We can use either technique, start in the slope-intercept form or start in the point-slope form, and end up in the same place. Okay, in our next example, they want us to find the general form for a line that passes through the points for 7 and -2, 6. Now, even though it's asking us for the general form, that's not the form we're going to start out with. We're going to have to start out with one of our other forms to get the information that we know. Remember, we said there's 2 things we need to figure out: the slope and a point. Well, they've given us 2 points. We can use either one for our line, but the slope wasn't given to us this time, so we need to calculate that. And this is a formula I'm sure you've seen before: change in y over change in x, or the rise over the run. So we'll plug in our points here. 6 minus 7 for our y values, and -2 minus 4 for our x values. When we start to do the math here, we get -1 over -6. Those negatives cancel each other, so the slope we want to use for this problem is 1/6. And again, we could use either of these points they gave us. I'm just going to use the first one. And I'm going to use that point-slope form because I think the calculations are a little easier when we do that. So I'll plug in what I know: y minus y1, the y value is 7, and our slope is 1/6, and x minus x1, our x value is 4. This is the equation of the line we're looking for, but it's not in the general form, so I'm going to go ahead and distribute that 1/6. And then general form, usually we don't have any fractions, so I want to get rid of those fractions. I'm going to do that by multiplying the entire equation by 6, both sides, every term. So we get 6y minus 42 equals, here the 1/6 times 6 cancels, and we just have x. 4/6, the denominator cancels, and we just get the minus 4. General form means we need our x's and y's on the same side. So I'll move my x over. And we need all our constants on the other side, so I'll add that 42. And usually for general form, we would like this leading term to be positive, so now I'll just multiply everything by -1. So I get x minus 6y equals -38. That's the equation of the line we were looking for in general form. Now there's a couple other ways we could get the information we need, the slope and the point. This one tells us to find the slope-intercept form of a line parallel to y equals -2x plus 3 and passing through the point -2, +3. So again, there's our point, done with that. To find our slope, we're going to have to use this information right here, the fact that it's parallel to the line they gave us. What we know about parallel lines and their slopes is that parallel lines have equal slopes. So the slope of this line, because it is in slope-intercept form, we can tell the slope of this line is -2. So that's also the slope we want for the line that we're about to write. Okay, so now we have the slope and we have a point. And so basically at this point, it's the same procedure we did on the last problem. Y minus y1 equals m times x minus x1. This time it asks for slope-intercept form, so we need to move things around a little bit. Well, these two negatives, first of all, will cancel each other, so we'll get an x plus 2 in there, and I'll distribute this -2. And for slope-intercept form, we would want to solve for y. And the equation of the line we're looking for is -2x minus 1. And since our line is in slope-intercept form, we can see we have -2 for a slope here and -2 for the slope of the line we were parallel to. So that works out. Everything checks. Another type of piece of information about the slope could be if they tell us we need a line that is perpendicular to a certain line and passing through a point -1, 4. Again, the point's given to us, so that's straightforward. And this time, this is the information we need to use to find our slope. Okay, for slopes of perpendicular lines, we know that the slopes are negative reciprocals of each other. So what that means is we need to find the slope of the line they gave us up here, and then we will take its negative reciprocal, and that will be the slope we want to use for our new line that we are going to write. So let's start off with this equation that they gave us. If we would solve this for y, we would have slope-intercept form, and then we'd be able to pull the slope off of there easily. So let's do that. Divide both sides by 3. So the slope-intercept form of the line they gave us in the problem looks like this. This is the slope of the line given in the problem. That's not the slope we want to use. Remember, we need the negative reciprocal. We need the slope that is perpendicular to that. So the perpendicular slope is we flip this equation upside down and change the sign. So the slope that we want to use in our problem is a +3/2. Okay. Again, it'll start to get very similar once we know these two pieces of information. The procedure is the same each time. Maybe since I did a lot of examples with point slope form, maybe I'll use slope intercept form this time. Okay, so I'll put in my x and y values and my slope so I can find my y-intercept. So that is 4 equals negative 3/2 plus b. We have to add 3/2 to both sides. 4 is 8/2, so we would have 11 over 2 is our y-intercept. So our equation looks like this. Our slope is 3/2, and our y-intercept is 11/2. This is the equation of the line we're looking for, but we need to go back to the problem. It asks for general form, so we need to fix this up a little bit. We'll get rid of those fractions by multiplying everything by 2. And then we need our x's and y's on the same side, so I'll move that 3x over to the other side. And scroll down just a little bit here. Finally, we'd like that leading term usually to be positive, so I will multiply everything by -1, which just flips all those signs for me. And there's the equation of the line that we were looking for. Okay, for our last example here, we want to find the slope-intercept form of the perpendicular bisector of the segment with endpoints -1, 6 and 3, 4. So we need to talk about what a perpendicular bisector is. Let's draw ourselves a little picture so we can get an idea of what's going on here. Sorry, that's a little crooked. Let me fix that. Okay, so let's draw ourselves a little axis over here. This doesn't have to be very good, just a quick sketch so we can see what's going on. So we have a line segment here with endpoints -1, 6, which maybe would be about here, and 3, 4, which maybe would be right here. So our line segment connects those 2 points. And we are looking for the perpendicular bisector of this line segment. So the word bisector, that gives us one piece of information. Bisector means it cuts our line in half. So we want our new line to pass through this point right in the middle. That's what bisector means, cut it in half. And the perpendicular gives us our other piece of information. That means we want it to be perpendicular to the line segment given. So we're going to have to use that idea again of a negative reciprocal for the slope. Okay, so first of all, let's find that point right there, that bisector point. And we have a formula that lets us do that, and that's the midpoint formula. Excuse me. To find the midpoint, remember we add up those x coordinates and divide by 2, basically just calculating an average. Add up those y coordinates and divide by 2. So our midpoint is 2 over 2, 10 over 2, or 1, 5. That's the point that we want our line to pass through. That's what we're going to use. And if you look at our graph, I mean, this was just a quick sketch, but it looks like that matches that point. The other piece of information we need would be the slope. Sorry, I had to pause for a minute there. We just had a fire drill. But I think what I was saying was perpendicular is the other piece of information that we'll use. And we'll use that to find the slope of this line we're looking for. So first we have to find the slope of the line segment that we were given. Again, that slope formula, y2 minus y1 over x2 minus x1. So we get -2 over 4, or -1/2. Remember, that's not the slope we want to use. We need the slope that is perpendicular to that negative reciprocal. So we flip it and change the sign. So we are going to use a slope of +2. There's our two pieces of information. We'll plug those into that point slope form. Y minus y1 equals m times x minus x1. Our answer needs to be in slope-intercept form, so we just need to do a little bit of cleaning things up here. We'll distribute that 2, and then add 5 to both sides. Y equals 2x plus 3. That's the slope-intercept form of our perpendicular bisector.